Databricks. Databricks.
All right, let's jump right into it. Today, we're going to demystify one of the biggest names in the data world, Databricks. You know, if you've ever found yourself wondering how companies like Netflix or Amazon deal with just mind-boggling amounts of data, well, this is for you. We're going to break it all down.
Okay, so first, let's set the stage with a basic problem. How do you actually process data when you have just too much of it? I mean, think about a terabyte of data. That's 1,000 gigabytes. Your souped-up gaming PC, the most powerful server you can buy? Nope, neither can load all of that into memory at once. It's just not possible. And this isn't some niche issue. This is the problem that almost every big company is wrestling with right now. So what do?
And that right there brings us to what we call the big data problem. It's really all about hitting a physical wall. There's just a hard limit to what one single computer can do. I mean, sure, you can try to just keep upgrading a single machine. Throw more RAM at it, get a faster CPU, slap in a bigger hard drive, but at some point you just max out. There's nowhere else to go. That's called vertical scaling, and when it comes to big data, it's a total dead end. You just can't build a single computer that's beefy enough for the job.
So that leads to this really cool idea. Instead of building up, scaling vertically, what if you build out? What if you could take all the computers in a lab or a whole data center and get them to act like one giant powerful machine? That's the light bulb moment. This idea, called horizontal scaling, is the absolute key to unlocking the world of big data.
And the engine that really makes this whole idea a reality? Well, that's Apache Spark. Think of it as the powerhouse under the hood of everything we're about to talk about with Databricks.
So Spark is all about a concept called distributed computing. And it's pretty simple, really. Instead of one computer trying to do everything, you create a whole team, a cluster of computers, or nodes, that all work on the problem together, in parallel. Teamwork makes the dream work, right?
And here's how that works in practice. You take that massive terabyte of data, and you just slice it up into smaller, bite-sized chunks. Then, each computer in your cluster grabs one of those chunks and gets to work on it, all at the exact same time. Once they're all finished with their little piece, the results are all combined back together. It's kind of like having 100 chefs in a kitchen all chopping vegetables at once, instead of just one person doing everything. The job gets done exponentially faster. It's just a brilliant approach.
But wait, if you have 100 chefs, you need a head chef, right? Someone to run the show. And that's exactly how Spark's architecture works. You've got one computer called the driver node, that's the manager. It doesn't do any of the actual data crunching. Its job is to figure out the plan, break up the work, and hand out assignments. And then you have the worker nodes. These are your team, the ones in the trenches doing all the heavy lifting, executing the instructions they get from the driver.
Okay, so this all sounds amazing in theory. Just spin up 100 computers and go. But, and this is a big but, actually setting up and managing a Spark cluster on your own is, well, it's a nightmare. It's incredibly complex. And that's where Databricks finally enters the picture. See, raw Apache Spark is just the engine, a super powerful engine for sure, but you still have to build the entire car around it. You've got to deal with networking, machine provisioning, software installation, security, making sure everything talks to everything else without falling over. Honestly, it takes a small army of very specialized, very expensive engineers to get it right.
And this is why Databricks is so huge. It takes that raw, powerful, but super complicated Spark engine and wraps it all up in a beautiful, user-friendly platform. It handles all that messy cluster management stuff for you. It gives your teams these collaborative notebooks to work in. I love this phrase for it. Databricks is basically the easy button for big data.
But the story doesn't stop there. Databricks isn't just about making Spark easier to use. The thing that truly revolutionized the game, the innovation that changed the entire data industry, is something called Delta Lake. Now, to really get why Delta Lake is such a big deal, you need to know about the old way of doing things. For years, the idea was to just dump all your raw data into something called a data lake. But the reality? These data lakes were often total disasters. They were unreliable. A process could fail halfway through and just leave corrupted, garbage data behind. They quickly turned into data swamps, murky, messy, and pretty much useless. Delta Lake is the fix for that swamp. It's a storage layer that you put right on top of your data lake. And what it does is it brings the kind of rock-solid reliability you'd expect from a traditional old-school database. We're talking about something called ACID transactions, which basically guarantees your data operations won't fail in a messy way. So you get the massive scale of a data lake, but with the trustworthiness of a database. It's really the best of both worlds.
So, you're probably wondering, how does it do that? What's the secret sauce?
Well, part one is that the data itself is stored in a super efficient open format called parquet. Now, unlike a spreadsheet that stores data row by row, parquet stores it in columns. Why does that matter? It means when you want to analyze something, you can just grab the exact columns you need instead of reading the whole file. It's way, way faster. But that's not even the main trick.
Here's the real magic. Alongside all those data files, Delta Lake adds one crucial thing: a transaction log. You can think of it like a bank's ledger. It's a single source of truth that meticulously records every single thing that ever happens to the data. Every new piece of data added, every row updated, every single deletion, it's all logged.
And this little log file, it is a total game changer. First, it's what gives you that reliability. A change is only final once it's written to the log, so you never get half-finished, corrupted data. Second, and this is super cool, because the log is a perfect history of everything, it lets you time travel. Yeah, you heard me. You can instantly see what your data looked like yesterday, or last week, or a year ago, and even restore it. And finally, it makes everything faster, because now Spark can just look at this small log to figure out which data files it needs to read, instead of having to scan everything.
Okay, so now that we get what makes Delta Lake so powerful, let's get practical. If you're using Databricks, one of the first big decisions you have to make is whether to use a managed table or an external table, and this choice really matters.
And really, it all comes down to one simple question. When you create a table, who's in charge of the underlying data files? Is Databricks managing them, or are you?
Let's look at this side by side, because it is super important. With a managed table, Databricks is the boss. It decides where to put the data files, and, this is the critical part, if you type drop table, it deletes not just the table definition, but all your data, too. Poof, gone. So it's good for quick tests, but maybe not your company's most important asset. Now, with an external table, you tell Databricks where the data lives, in your own cloud storage. If you drop an external table, Databricks only forgets that the table exists. Your actual data files are completely safe and sound, right where you left them. This is absolutely the way to go for any real production data.
So here's the bottom line, the thing you really need to remember. For any data that actually matters, any data that you need to protect and govern, you want to use external tables. Period. This idea of separating the definition of a table from the actual data is a cornerstone of building a solid data platform.
And when you put all of this together, you take the raw power of Spark, you wrap it in the easy-to-use Databricks platform, and you add the rock-solid reliability of Delta Lake, you get this new big idea, the Lakehouse. And it's exactly what it sounds like. It's an architecture that gives you the structure and trust of a traditional data warehouse, combined with the massive scale and flexibility of a data lake. What that means is a company can now run its machine learning models on the exact same data it uses for its critical financial reports, all in one place. No more moving data around. So it really leaves us with this huge question. Is the Lakehouse the undisputed future? Is this the way we're all going to be building our data systems from now on? It's definitely looking that way.